Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 3 video from the chapter of surface areas and volumes, I will be solving set 2 of 6 conceptual problems based on the concept of surface areas and volumes of right circular cylinder, which I term as RCC. The key concepts and formulas about surface areas and volumes of RCC was discussed in part 1. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, the first problem says, if the diameter of the base of a closed RCC be equal to its height, then its whole surface area is, whole surface area means total surface area, which is TSA. Now diameter, which is twice R, if R is the radius of the base of a RCC, that is right circular cylinder, so twice R is given to be equal to H. Then what is whole surface area means the total surface area, which is TSA. TSA we know is equal to, now I never remember the formulas by heart. I always try to visualize what is TSA and what is LSA. Only I remember is volume, which is pi r square h. The lateral surface area and the whole surface area or total surface area, I always try to derive trying to visualize it and from the fundamental concept. So TSA is, I know, 2 into, since there are two bases, 2 into area of each base, which will be pi r square, and the LSA, LSA I know is 2 pi RH. Okay. So now you can say the formula was 2 pi r multiplied by r plus h. Now we know twice r is equal to h, so this will be h pi, and r is h by 2, h by 2 plus h. This is equal to h pi multiplied by 3h by 2, which is equal to 3 pi h square by 2. 3 pi h square by 2 is the will be the total surface area or the whole surface area of the RCC. So the correct choice is B. Now if I do any kind of if I solve any problem incorrectly, and if you find any error, it could be due to incorrectly applying the concept or applying wrong concept or doing any kind of silly calculation mistake. Please feel free to let me know in the comment section. I will highly appreciate that. And if you have any question or doubt, you need any kind of clarification on any concept, then also please let me know. I will do my best to address your query. Let's see the next problem. Question number 2. In a RCC, if the radius is halved and height is doubled, the volume will be same, doubled, halved, or 4 times. Okay. The volume. Okay. So initially, let's say the volume V1 we know is, the formula is pi r square h. It will be pi r square h. What will be V2? V2 is the volume when the radius is halved and the height is doubled. It will be pi. Radius is halved means radius will become r by 2 square, and the height is doubled, which means it will be twice h. This is equal to, if you simplify this, it will be pi r square h by 2, which is of course equal to V1 by 2. So the volume will be halved. The correct choice is C. Okay, let's see the next problem. Two RCCs of equal volume have their heights in the ratio 1:2. Ratio of their radii means the ratio of their radius or base radius of their bases. We have to find the ratio of the radius of the bases. Okay. So let's say let h1, that is the height of the first RCC based on the ratio, be x, and h2, which is the height of the second RCC, be twice x. The two RCCs have equal volume. Okay, the two RCCs have equal volume, but we do not know the radii. Okay, so let's say the radius, the base radius of the first RCC is R1 and the base radius of the second RCC is R2. So V1, a volume of the first RCC, if I call it V1, will be equal to pi R1 square H1, which is equal to pi R1 square X. And what will be V2, the volume of the second RCC? It will be pi R2 square. R2 we are considering to be the base. R1 and R2 are the radius of the base of first RCC and second RCC. H2, this will be equal to, H2 is twice x, so this is 2 pi R2 square x. So this is equal to pi x R1 square, and this is equal to 2 pi x R2 square. Now it is given the two RCCs are having equal volume. So we have V1 equal to V2. This will imply pi x R1 square will be equal to 2 pi x R2 square. So this implies, from here we can easily, pi x will cancel out, we can easily get the ratio of R1 and R2. So we have R1 square by R2 square is equal to 2. This implies R1 by R2 will be equal to square root of 2, and this implies R1 is to R2 is equal to square root of 2 is to 1. So the ratio of the radius of the bases of the two RCCs will be square root of 2 is to 1. So the correct choice is B. B is the correct choice. Okay, let's see the next problem. The sum of the radius of the base of a solid RCC and the height is 15 centimeter. The sum of the radius of the base of a solid RCC and height is 15 centimeter. So we have R plus H is equal to 15. Now I won't be mentioning the units. I hope you will understand. Now if the TSA means the total surface area is 660 centimeter square, then the volume of the RCC is, what is TSA? Total surface area, the area of the two bases, 2 into area of each base is pi r square, so 2 into pi r square plus the area, the lateral surface area, which is 2 pi r h. Okay, this is equal to, we know the formula is 2 pi r multiplied by r plus h. This is equal to r plus h is given as 15, so this will be equal to 2 pi r multiplied by 15, this is 30 pi r. Now the total surface area is given to be 660 centimeter square, so we must have 30 pi r is equal to 660. This implies pi r is equal to 660 divided by 30, which is 22. Pi r is 22. Now then the volume of the RCC is if the TSA is 660 centimeter square, oh, the height is given. Oh no, the sum of the radius of the base of solid RCC and height is 15 centimeter. Okay, fine. Now let me see. Oh, so pi r is now this implies Now, if you are not given the value of pi is, you must know that the value of pi, you should always use the value of pi. If no value is given for pi, always use the value of pi as 22 by 7. So this implies 22 r by 7 is equal to 22. This implies r is equal to 7 centimeter. Obviously, then we will have h is equal to 15 minus 7, which is 8. So height is 8 centimeter and r is 7 centimeter. So then volume we know is pi r square h. Pi r square h. Pi is 22 by 7. R square means 7 square. H is 8. This is 154 multiplied by 8, this much centimeter cube. This should be 32 1232 centimeter cube is the volume of the RCC. So the correct choice is A. A is the correct choice. Let's see the last problem, question number 5. The radius of the cross section of an inflated cycle tire is 7 centimeter. The distance of the center of the cross section from the axle is 20 centimeter. The volume of air in the tire is. The concept behind this problem I discussed in part 1 video. If you have missed the part 1 video, I strongly suggest that you please watch that video to have a good understanding of the concepts and formula of surface areas and volumes of right circular cylinder. Now, regarding an inflated cycle tire, so this is an inflated cycle tire. We have this. So this is now the cross section. So these are the cross section. You can consider. So this is the cross section of the tire. These are all cross section. This is the center. This is the center. Let's say this is another cross section. This is the center. Another cross section. This is the center, and this is the axle. Now it is given the distance of the center of cross section. That is the center of any cross section of the tire from the axle is 20 centimeter. Meaning, let's say the axle point is O, and let's say these are the centers C1, C2, C3, C4. The distances of C1, C2, C3, C4 from O, they are all same, which is given as 20 centimeter. Now, what will be it is asking to find the volume of air in the tire. Basically, you have to visualize the tire as a RCC, that is right circular cylinder. How? Obviously, if you vertically cut the tire and flatten it out, it will look like a RCC. It will look like this, somewhat like this. Let's say if you have vertically cut out, let's say you have vertically cut this tire and flatten it out, it will look like this. So the radius of the cross section is given as 7 centimeter, meaning this part, obviously this is twice r. The diameter of the cross section, this is twice r, where small r is given as, radius is given as 7 centimeter. So similarly, if you this is the diameter, this is also twice r, where r is equal to 7 centimeter. So we can clearly see, if you consider the entire tire as a RCC, then the radius of the RCC will be the radius of the cross section of the tire. Now what will be the length? And also we can see that the volume of the RCC will be equal to the volume of air of air inside the tire. Now to find the volume of the RCC, we need the height. What will be this height? We need this height. This height is nothing but the length of the tire. If you flatten, if you cut this tire and flatten it out, the length of the tire is basically will be the height of the RCC. What will be that length? That length will be the circumference of a circle having radius, which is equal to the distance of the center of the cross section of the tire from the axle. That is, this h will be equal to 2 pi. The circumference of a circle of radius r is 2 pi r, and basically if you join the center of every cross section of the tire, it will be a circle obviously, and this circle will have a radius of 20 centimeter, and the circumference of this dotted circle is actually will be equal to the length of the RCC or height of the RCC. So the height will be 2 pi into 20, this much centimeter. So then what is the volume of the RCC? Volume of the RCC is equal to the volume of air in the tire. It will be pi r. What is r? R is 7 square. H, what is h? H is 2 pi into 20. So this is equal to 40 pi square multiplied by 7 square. Now you will put the value of pi as 22 by 7. So 22 square multiplied by 7 square multiplied by 7 square. 7 square cancels out. So this is, how much is 22 square? 22 multiplied by 22 is 44, 484. So this will be 484 multiplied by 40 is 16, 32, 33, 19360 centimeter cube should be the volume of air in the tire. 19360. So the correct choice is A. This is a very conceptual problem. You must definitely solve this problem and understand the concept. How we are visualizing an inflated tire of a bicycle as an RCC, that is the cross section, the radius of the cross section of the tire will be equal to the radius of the RCC, and the height of the RCC will be equal to the circumference of a circle whose radius is equal to the distance of the center of the cross section of the tire from the axle point. So that is all for 6. Oh, I think I have another problem. Oh, one more problem left. The largest possible RCC is cut out from a wooden cube of age 7 centimeter. The volume of the wood left over after cutting the RCC is. So this concept I have also discussed in part 1 video. The base radius, when you cut out the largest RCC from a cube, if you consider, so basically the two bases of the RCC will lie on two opposite faces of the cube, and the radius. So let's say this is one face of the cube, and this is the base. This is one base of the RCC. So the radius of the base of the RCC will be equal to half of the edge length of the cube. So R will be equal to A by 2, which is A, which is the side length or edge length of the cube, is given as 7. So this will be 7 by 2. That is the radius of the largest RCC that is cut out from a cube should be equal to the half of the side length of the cube. What will be the height? Height will be equal to the edge length or side length of the cube, which is equal to 7. So then what is the volume of largest possible, then what is the volume of the of wood cut out, which is in the form of RCC? Let's say that volume be V2, and let's say V1 is the volume of the cube. The volume of the cube will be 7 cube. Okay. Okay. So this is 49 multiplied by 7, which is equal to 63, 28, 31, 316 centimeter cube. Now what is V2? V2 is the volume of the largest possible RCC that is cut out. It will be pi r square h, where r is 7 by 2 square multiplied by h is 7. So this is equal to pi 7 cube is 316 by 8. Okay. So then what is the volume of wood left after cutting the RCC? It will be equal to V1. So V left, volume of wood left after the largest possible RCC is cut out from the cube is equal to V1, volume of the cube, minus volume of the largest possible RCC that is cut out. This is equal to 316 minus pi multiplied by 316 divided by 8. If I take 316 common, I have 316 multiplied by 1 minus pi by 8. Pi by 8 means 22. Pi is 22 by 7. This is equal to 316 multiplied by 1 minus 22 by 56, which is equal to 316 multiplied by 1 minus 22 by 56. If I simplify this, it will be 34 by 56. Now what will be this? 749. And then 17. How much is 49 multiplied by 17? 63, 28, 34, 49, 3, 3, 8. So this is 833 by 4 centimeter cube. Now how much is 833 by 4? My answer will match with any of the choices. Let me see if I have done any silly mistake or not. The radius of the largest possible RCC will be equal to the edge length by 2, a by 2, where a is the edge length of the cube, which is 7. So r is a by 2, which is 7 by 2, and edge height will be equal to the edge length, which is 7. So then the volume of the RCC, largest possible RCC, will be pi r square h, which is pi 7 by 2 square multiplied by 7, which is I did a mistake over here. This will not be 8, this will be 4. This is 4. So this is 4. This will be 4. This is 4. Okay, let me do it again. So this is 4. Now this is 316 multiplied by 1 minus pi by 4. 316 multiplied by 1 minus 22 by 7 multiplied by 4, which is 316 multiplied by 1 minus 22 by 28, which is 316 multiplied by 6 divided by 28. 7 4 7 4 7 49. What? No. 316. 49 multiplied by 7. How can this be 316? 63, 28, 34, 343. 343. So these are all 343. 343. This will also be 343. 343. 343. 343. 343. 343. Okay, so now this will be 343 multiplied by 6 divided by 28. 7 4 7 49. 2 2 2 3. 27. 147 by 2, which is equal to 73.5. 73.5 centimeter cube will be the volume of wood left after the largest possible RCC is cut out from the cube. So the correct choice is A. So with this, it comes to an end in solving 6 conceptual problems of set 2 based on the surface area and volume of an RCC, that is right circular cylinder. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Please stay tuned for more solving videos to come on right circular cylinder. I am ending the video here. Thanks for watching, and until the next video, take care and bye.